We're going to use the RidleyBox to measure impedance of batteries. It's a very popular topic these days. So let's get started with that. If you need more information on everything we do, remember to go to ridleyengineering.com. So here's the RidleyBox. The first step in the process is, of course, to get yourself a RidleyBox, or you can go for our higher end, fully calibrated AP instruments machine if you like, and do these measurements. It's the same setup. So the first thing you do is get your RidleyBox, and then we connect the output of the RidleyBox to the input of our injection isolator, which is built into the product. The next step is to connect the output of the isolation transformer to the input of our impedance tester. And this impedance test can be used for batteries, power supplies, anything that has a voltage on it that may be high, low impedance, you name it. Then we connect channel A of our analyzer to the impedance tester. This will be the current sense port for the measurement. We'll connect the current drive from the impedance tester to the device under test. In this case, it's a Milwaukee 18-volt lithium battery that we're wanting to measure the impedance of. And then finally, we connect channel D of the impedance tester to the terminals of the battery. Notice that we're establishing a 4-terminal Kelvin connection here. That lets us measure impedances down below 1 milliohm, even smaller than that. Our next step is to go to our frequency response analyzer software right here. So here's the opening page of that, and we turn the analyzer on. We're connecting. Notice for all our software we use the very convenient interface of Excel, because all the data is going to flow into Excel and everybody knows how to run that. We select output impedance as a measurement here. And for your convenience, it shows you the connection that I just showed you. In this case, it's shown for our switching power supply that we use in our workshops. We click OK. And then we click on Sweep. Notice that when we click on output impedance, all the parameters for the analyzer are set up exactly the way you want them. The frequency range, the bandwidth, the signal size, everything is optimized for the measurement quantity that you're looking for. So we have lots of powered impedance, we have plants, loop gains, power supply rejection ratio, 10 Hertz to maximum, and a PFC loop are a bunch. And then, of course, we can measure a bunch of components as well.
Sweep complete.
Okay, the sweep is complete. We've gone out to 400 kilohertz. Now we can actually save that data set once you're happy with the data that you got. And we call that battery impedance. Okay. Then I'm actually going to save it again and specify specifically which battery it is that we're testing here. 18 volt. Okay. So now you can see that we have the impedance here plotted versus frequency. And just to figure out what the impedances are, we can add a component on top of this. Let's click on our component, an inductor and a resistor.
Inductor reference generated.
So we now plot that reference over the top of the measured waveforms. And here you can see we're measuring a minimum of about 65 milliohms and an equivalent inductance of approximately 250 nanohenries. Of course, you can see the slope of the measurements are not really going up with a +1 slope. It's a more complex impedance than that. But you can see how useful this reference trace is for you. So there you go. We have the battery impedance recorded. Very simple experiment to do. And now let's go back to our presentation. And you can see that impedance there. Here's the impedance again with the reference trace on it. And If you want to learn more about what we're doing, just to let you know, we're having a one-day power design workshop with myself in San Antonio next March. And there's two registrations here. One is for regular working people in industry at $600, and student registration is available as well for just $200. We have a limited number of student spaces available. So I hope you've enjoyed this presentation. We'll be back with more presentations about how to use the RidleyBox. Thank you.